Okay, we will start now. So today's lesson is electrical engineer practice. So electrical engineer practice is for the Bachelor of Applied Engineering. And also I will present you the electrical engineer workshop practice and also advanced diploma courses. So firstly, we're talking about the electrical engineer practice. For the electrical engineer practice, we can start from the aspect. So that will be the most important one is we have to be aware of the specification, and also the rule and regulation and the rate assessment of the electrical engineer. Those are the important aspects for the electrical engineer. So in this case, we have to be aware of in the electrical, when we are practicing the electrical engineer, we have to refer the appropriate rule and regulation. So in the state of the New South Wales of Australia, they are the New South Wales Electrical Service Rule. So this one is govern the electricity supply and the distribution, and also the electrical safety of the personal properties. So those are important aspects for the electrical safety of the personal properties. So that every electrical engineer and every worker, they must have the duty of care. The duty of care means an honest practice in the technical aspect as well as a legal responsibility. So when we are doing your professional job or the technical job, you must be honest practice. You must do this. You must act according with the honest practice, as well as you have to take the legal responsibility. So the New South Wales Work Health and Safety Act 2011 is the main rule and regulation which govern the safety in the New South Wales. So the safe work practice is an important aspect when we are doing the safe work practice. All the physical activity and the chemical and the biological aspects and also the ergonomics and the emergencies practice, those are related to the safe work practice. So we are doing the job. In this case, you have to reasonably take care of your practice, and also every workplace has the workplace safety committee. So those workplace safety committee consists of the employer representative and also employee representatives, also union delegates. In the meantime, public relations, publics are also take part in those safety committees. So those are aspects of the safety committee. So when the serious injury happen, so in this case are two aspects. So you are doing the causing a serious injury because of you are breach of the duty of care. In this case, you will be responsible for the legal aspect. So you can face a legal action. So in this case, breach of the duty of care is not only the civil case, can also lead to the criminal case. So therefore, in the electrical industry, we have to be refer the appropriate rule and regulation. So AS 3000. So this is for the Australian electrical wiring rule. This electrical wiring rule is AS 3000 is now the 2018 edition. So we have to refer the latest edition. So those AS 3000 rules include the design, construction, testing, and the selection of the electrical installation. So those are the aspects. We are installing the electrical system in the industry. We have to refer the AS 3000 rule. In the meantime, we need to utilize the AS 3000 rule to install the electrical equipment. So in the meantime, this is for the utilization. Consumers utilization, we can utilize the AS 3000 rule. In the meantime, when we are doing the energy supply and the distribution, we have to refer the New South Wales Electrical Service Rule. So this New South Wales Electrical Service Rule is for the supply and distribution aspect. So in this case, this supply and distribution aspect are called as the routine. When we are doing the electrical installation in the building, we have to utilize the New South Wales AS 3000 rule, but for the supply and distribution, we have to utilize the AS 3000. So supply and distribution is AS 3000 New South Wales Electrical Service Rule, but for you are doing the consumer side of the electrical installation, we have to refer the AS 3000. So this 3000 rule got the two parts. One part is a safety and a standard, and part two is a practice. So part one is safety, and part two is a practice. The two parts are included in the AS 3000 rule. Therefore, we are doing the NDs so this 3002 is a part one is a safety and standard. So the part one explain the technical meaning, what is a safety standard, what are the aspects they are explained in the part one. But the part two is a real practice. When we are doing the electrical selecting the cable or we are to terminating or we are doing any other system. In this case, we have to refer to the part two. So this is the overview of the electrical practice in the Austrian industry. So any things before you are doing this job. So first thing is that you have to focus on the risk assessment. So the risk is the most important aspect. Risk control is important. So that we have to do the risk control. Risk control includes the elimination, containment, and the reducing. The first thing is that anything can cause any injury or any damage. The first aspect, the best one is that we have to do this elimination. So you have to eliminate totally. Instead of the dangerous equipment, we have to replace with the any equipment that do not get any danger. So this is the first thing. And also the containment. Containment means any dangerous machinery need to be put into the enclosure, appropriate enclosure. They have to utilize the appropriate enclosure to control and to retain and contain any dangerous material. And reduce means that if you cannot eliminate or you cannot contain, the best thing is that you have to reduce the dangers. So that in this case, reduce the danger means you have to utilize the personal protective equipment. So in this phase, we have to be aware of any hazards. So hazard can cause the physical and the work environment or the equipment or the work tasks and the work design. We have to utilize those aspects to reduce the hazards as much as we can. So the physical work environment we have to provide the appropriate safe work environment for the workers and the people in the industry. In this case, our working practice and the equipment, we have to be modifying the equipment we have to regularly check the equipment to get a safety standard. And what that is appropriate safe work practice need to be utilized, and what design must be the safe work design. So in this case, we are doing any risk assessment. So what type of the risk can cause to the people in the industry. This is the important aspect. So the risk can be the severity. Some of the risks are the varies can cause the serious injury or that can cause the death. And so this is for the how severe about the risks. What kind of the damage can happen in. So this is the risk assessment. If any equipment can cause the death of the people, for example, electricity can cause a death. So this is a very severe. So how much probability can happen? So probability assessment in the some time, it can be very high risk, but some other probability reduced. So we have to assess any probability. Another thing is a risk level. How often risk can happen? So this is the risk level assessment. So the risk assessment include the how much severity can happen or what about the probability and what is the risk level. So those are we have to know about the thing. So in this case, when we are assessing the risk, they are the 5 levels of the risk control. Then risk alert 5 is the highest one. This is the almost certain. So anyone who create the light electrical circuit will be electrocute. So this is the almost certain. Some are the likely, some are possible, unlikely, and rare. So those are the safety risk assessment level. In the meantime, what happened, the consequences. So any consequences can cause the catastrophic in there, and these are danger or any burning or the household can happen to the catastrophic. And some other major damage can happen, some moderate damage happen, minor damage, and the insignificant. Those are the level of the consequences. Therefore, when we are writing the planning the risk assessment control panel, we have to draw the table. So that this is what this column include the consequence, and here is a horizontal line include the likelihood. So that because of this one, in this case, the range can be there's this is we're going to rare or the high or medium or the very low. Those things you have to put into the this cell. So by this way, we can assess a reassessment. So there will be the risk will be the high risk or medium risk, low risk or very low and low. Those things are we have to put into the this table. So that before you are starting the as an engineers, before you start in the any job, now you have to control the risks. So that there are the risk control aspect. Level one will be the eliminate the hazard. We have to eliminate the all hazards together. So this means that we have to replace all the dangerous equipment. Level two means that you have to substitute the hazard. Substitute the hazard with the something safer. So if you cannot eliminate that equipment, you have to utilize any safer equipment. And another thing that we have to isolate the hazards. We have to isolate the hazards from the people. This means the appropriate container, appropriate barrier you must have provided to protect the people, not to get any injury or any damage. And also we have to reduce the risks. We have to reduce the engineering design and any other control aspect we have to apply, and by this way you have to reduce the risks. Level 3 means we have to reduce the hazard by using the administrative action. Administrative action means the appropriate assigning the rotation of the job or the appropriate assigning the work environment or the workplace. For example, sunburn. Sunburn is a very serious for the construction worker. When we are working at the outside without any shade, and then during the very hot day or the summer, peak summer time, about 12 to 2 p.m. is the most serious thing. So that times the sun rays can fall into the body very much. So in this case, we have to reduce that risk. So to reduce that risk, the best thing is you have to rotate the shade. Instead of asking the worker to do the outside job, the administration allow the worker to walk into the shade. So this is the things we have to administrative fashion. So those are the important aspect of the reassessment. So this table means any reassessment before you are doing any reassessment, we have to follow the appropriate reassessment procedure, and we have to identify the risk, any danger we have to identify, and we have to control those danger as well. So this means that reassessment is important for the here is we need the government control. Government need to control the appropriate rule and regulation. In the meantime, those government actions need to be followed by the contractor and these service department. In the meantime, we also have to produce appropriate new report. So the safety inspectors have to provide the news and report. And then those reports are included the visual inspection, identify the problem, propose additional things. So those are important aspects of the reassessment. So that in the meantime, those are reassessments that you have to site visit, and also we have to identify the problem. In this case, include the visual inspection, identify the possible problem. Those are prepared by the reassessment report. Those reports are submitted to the government, and the appropriate legislation is imposed by the government. And those then appropriate rule regulations are produced by the government authority, and the contractor and the service people must follow them. So this is an important aspect of the reassessment. So in this case, we have to apply the appropriate occupational health safety plan. So in this case, you are doing any solar electrical installation. In this case, you have to follow the appropriate solar electrical safety. When you are working at the height, appropriate working with the heights at the heights of safety, and also the electrical safety, heat temperature safety, important aspect. In the meantime, we have to also assess the risks, and also the electrical safety aspect, also the environment protection. Those are the important aspects of the reassessment. So that before you doing anything as an engineer, appropriate communities cooperation is also important. Computer licensing is also important aspect. So that any material acquirement, project schedule tasks, and also they cooperate with the community is important aspect of the electrical engineer. So this so these electrical engineer must have the appropriate technical background. In the meantime, when we are doing the job, in this case, you also have to do the appropriate ethics, professional ethics. Before you are finishing any contract job, you accept the job with the one company, so that when you are going with the next company, and that time another company offer you another job with the better pay and condition. So in this case, you have to be aware of. You cannot simply draw everything and you cannot go to the other side because of the it is an unethical. So you have to negotiate with your employer to refer your responsibility. You have to refer your current job or the current document to your current employer, and then appropriate substitution need to be determined by your employer. Everything okay, everything clear, then you can take up the another job. So this is the important aspect of the important aspect of this ethical process, ethical ethics. Therefore, as an engineer, your must have the appropriate design. So you have to design this your project. In the meantime, you have to manage a bid. So tenders are bid. Tender bids means that sometimes you have designed any estimate or design to win a tender. In this case, you have to utilize the appropriate rule, regulation, and standard, and appropriate pricing. You have to follow, and then utilize, and then you have to manage the tender bid. If you are the engineer who select any tender submitted by the contractor, in the meantime, you also have to be honestly do the practice. You have to see compare all the tender one to another, and also cost effectiveness, safety aspect, work procedure. Those you have to be properly defined, and then you have to select the appropriate tender. In this case, you have to be aware of the specification and the work procedure and the process. Those are the important aspects and very related to this technical background. So you got this knowledge and the technical background. You can design the tender and just do the designing. In the meantime, you can appropriate select the tender. So this is the first aspect. Another thing is that we have to utilize the appropriate tender bid to assess the application of the IDAS company. So those tender bids include the specification and the work procedure and the process. They are related to the finance. So that if you select the tender with a very high cost, in this case, your company will lose a profit. So this is why that selecting the tender is important aspect. If you select the tender with a very low price, but then no quality, in this case, your job can be damaged. So this is your reputation can also be damaged. So this is important aspect of your assessing the tender. So that you have to use that tender bid to assess the application of the other companies. So that as an engineer, you are responsible for the design and also the rate assessment, safety assessment, and the communities cooperation, and also the designing and the managing the tender bid or specification, work procedure. They are related to the finance. So this is an important aspect of the electrical engineer. So now things we are installing the electrical equipment, so we have to be aware of the protection system. Protection system is simply disconnect the supply when the touch voltage is greater than the 50 volt. This means that allowable touch voltage is 50 volt. So before you are disconnecting any equipment from the supply, you have to be aware of how much touch voltage can happen. So this is the formula to calculate the touch voltage. VT is a touch voltage. VO is an operating voltage. This means 240 volt system or single phase. ZPE means protected active contactors are impedance, and ZA means the impedance of active contactor. So this formula has been utilized. We use this formula to determine the touch voltage. For example, impedance of the active contactor is 1 ohm, and protected active contactor is 2.4 ohm, and the supply voltage 230 volt. In this case, we can calculate the touch voltage. VO multiplied ZB divided by ZA plus ZBE. So that this is the you can VOs are you substitute the 230 and ZBE is at 2.4, ZA1 plus 2.4. So then you can calculate the voltage. So this is what you can calculate the touch voltage. So as an electrical engineer, before you are disconnecting the anything, because of the especially that you are upgrading the electrical system, you have to disconnect the all electrical supply, all the wire, and you have to reinstall the whole system. So that before you are disconnecting the anything, you have to be aware of the touch voltage. This is a touch voltage calculation. Another thing is a for loop impedance. For loop impedance means this is for the V75 operation temperature, 75 degrees centigrade. V90 is operation temperature 90 degrees centigrade. When we are looking at the electrical cable, some cable you can see the V75, some got the V90. V75 operating temperature is 75 degrees centigrade. V90 is operation temperature is 90 degrees centigrade. And then we also have to aware of the for loop impedance. For loop impedance means the current flow from the source to earth. So this is the total impedance. So this system you can see that this is the equipment, electrical point of supply. This is the fault. So the electrical currents you can see that this is the consumer main. Consumer main, here is a main switch, and this is for the equipment. So this is E and D is this is the equipment we utilize this equipment. So those equipments are from this equipment. The electrical fault happens, therefore we come through the main supply and go to the supply neutral. So from the neutral side, it can go to this neutral bar and the up bar are connected. So that the current will go to this R. So that will be the total impedance can be calculated. Z is a ZAB. ZAB means from the A to B. Impedance. Here supplying the active conductor to A to B. So this is A supply, this is equipment point of supply. So from the conductor to the point of supply, ZAB. ZBC means here is you consider this is a B point, here is C point. So B to C point impedance. ZCD. So here this C point to the equipment is a ZCD. And also you can see there's a ZFG. FG is a external impedance. And also the ZGA. ZGA, so go to the other system. So this is for the Z external. Internal impedance is ZDE. So this is in the equipment you can see the impedance ZDE. So the total system impedance is Z external and Z internal. So external impedance AB plus BC plus CD plus FG plus GH. Internal impedance is DE. So by combining, then we got the total in system impedance. So this is the way we have to calculate the system impedance. So that in this program, we can see the supply transformer voltage is at 230 volt, and active conductor side 0.25 ohm, and also the ZB is at 3 ohm, and also the equipment impedance is this is all the 3 ohm, and also ZB is other system 3 ohm, and also from this up to the distribution board is a 0.15 ohm. So those are the impedance given. So that we can calculate the total for loop impedance by adding the all. So this is the way you can calculate the for loop impedance. So this will be we calculate the for loop impedance. So ZBA, ZA, ZAN, ZBE, ZBEN. So this is the thing we add. So this is the 9/5 So if you got a for loop impedance, you can also calculate any fault current. When the electrical fault happens, the current can be calculated. Supply voltage divided by impedance. Supply voltage by impedance, then you can calculate the fault current. So in this case, not to include the for loop impedance. If sometimes you don't need to use a for loop impedance, in this case you can put the for loop. This one is a ZA and is 0. then we can calculate the maximum fault current can also be calculated. So this is the way we are calculating the maximum fault current. So this problem is a supply transformer. Supply voltage 230 volt and circuit breaker. The rating is at 20 ampere and also the socket outlet is at 10 ampere. We have to calculate the for loop impedance. So in this case, how to calculate this for loop impedance? So in this case, this supply circuit breaker is type C. Type C circuit breaker. So we have to refer the ASR 3000 table 8.1. So type C circuit breaker, and then the current is a 1.53 20 ampere. So then this is the for loop impedance is a 1.530 ohm. So this is the way we can find out the for loop impedance. You refer the AS 3000. So AS 3000 rule and look at the table 8.1. So you can see this type of the circuit breaker. Type of the circuit breaker type C and current rating is at 20 ampere. So from the that table, you can get the for loop impedance is 1.50 ohm. 530 ohm. This is the way we find out how the for loop impedance. Okay, so this is the things AS3000 rule. So table 8.1. Table 8.1. Here is a table 8.1. So this problem, give the circuit breaker type C circuit breaker and 20 ampere rating. So what should be the for loop impedance? Therefore, you have to refer the AS3000 rule tables are 8.1. So this is table 8.1. So type C circuit breaker and 20 ampere here is a 1.5. So current, so for loop impedance is 1.5. So this is the way how we calculate the for loop impedance. So this is in this case, as an electrical engineer, you also need to know how the appropriate for loop impedance. So this is the appropriate for loop impedance calculation. So we have to refer the appropriate for loop impedance before you start doing the anything, any electrical installation. This is the for loop impedance, how we do the for loop impedance. So you refer the appropriate the EL0018 table. Now thing is we utilize the HRC fuse. HRC fuse is high rush charging capacity fuse. This fuse is we utilize to do this emergency cutting off the electrical supply. So in this case, HRC fuse is utilized. So HRC fuse rating is 25 MVR, 25 MVR. So the HRC fuse is operate within the 0.4 second. So in this case, we have to calculate the date installation. We have to calculate the for loop impedance. So we also have to refer the table 8.1, table 8.1 for the for loop. So we refer the EL3000 rule and table 8.1 as well. So we go to the section 8. So this is table 8.1. So table 8.1 means if you are installing the fuse on the final sub-circuit, there are two kinds of the fuse. HRC fuse has the 0.4 second operation time, and normal fuse are 5 second operation time. So in this problem, this one is given the 25 MVR rating, 25 MVR rating and the HRC fuse. So 25 MVR rating and HRC fuse, high rush charging capacity fuse. So the 25 MVR and the HRC fuse 0.4 second. You can see the Y6 ohm. So the Z4 impedance, for loop impedance is Y6 ohm. So from here you can calculate like this. So another thing is as an electrical engineer, you also need to set the circuit breaker. Well, when we are installing the electrical installation system, so that you have to protect your circuit. In this case, you need to utilize a appropriate circuit breaker. So this is a selection of the circuit breaker. There are three kinds of the circuit breaker. Type B is a 4 times rated current. Type C circuit breaker is 7.5 times rated current, and type D is a 17.5 times rated current. So there are three kinds of the circuit breaker we are using. So this problem is given the we are supplying the 100 ohm. So this motor or this coil got the 100 ohm. We connected to the 230 volt. So in this case, how much normal current is flowing into this system? So the 230 volt divided by the impedance 100 ohm, you got the 2.3 MVR. So this is normal current is 2.3 MVR. Then this is a normal saturation. Then electrical fault happen. Fault happen means the fault impedance it fall down to the 10 ohm. 10 ohm means that normal full circuit is impedance 100 ohm. But when the electrical fault happen, the impedance is reduced significantly. Therefore, they reduce impedance, and we have to utilize the supply voltage. So supply voltage divided by the reduced impedance. So 230 volt divided by 10 ohm, you got the 2.3 MVR. So this is for the fault current is fault current 23 MVR. So then we have to find out the ratio between the normal current and the fault current. So normal current is 2.3 MVR, fault current is 23. So divided by 23 by 2.3, you got a 10. So this ratio is a 10. So we have to find out the distance. What kind of the circuit breaker is suitable? Type A or type B or type C or type D. In this case, if type A is only 4 times rated current, type C is a 7.5 times. But here is a fault current and normal current ratio is 10. So this should be you can use a type C, but you can utilize the type D. Type D is up to 70.5 times. Therefore, you can utilize a type tidy circuit breaker. Tidy circuit breaker and also the 2.3 ampere. So then tidy circuit breaker 2.3 ampere, tidy circuit breaker and 2.3 ampere. So then you can find out the appropriate in so tidy circuit breaker 2.3 ampere. So 2.3 is in the you can see the ASR 3000 rule. Table 8.1, there is a no 2.3 ampere, minimum is 6. So the tidy circuit breaker and the protected rating is there is no 2.3, only 6 available. So you say utilize and tidy circuit breaker. So there will be the minimum maximum output impedance is 3.10. So this is the way we find out the output impedance. So this is the program I repeat again. We have to use a normal current, normal impedance 100 ohm. When the electrical fault happens, is a fault impedance 10 ohm. Supply voltage 230 volt. What kind of circuit breaker is suitable? So in this case, we have to find out we calculate the normal current first, normal voltage divided by normal impedance, and also that we calculate the fault current, so the supply voltage divided by fault impedance. Then you got the fault current, you got the normal current. Then we find out the ratio. Fault current divided by normal current, so you got the ratio is 10. Then you can see the 4 kinds of the circuit breaker, type B or type C or type D. So we have to utilize the type D because of the ratio between the normal current and the fault current is a 10. So type D is a suitable. So you have to select the type D. Type D and also the what about the current? The normal current 2.3. So 2.3 ampere. This 2.3 ampere and type D. So then you can look at the tables 8.1. So type D 2.3. There is a no 2.3. The minimum is 6. So the 6 ampere you select and type D. So in this case, you find out the follow impedance 3.1. So this is the way how we find out the follow impedance for this system. You know the normal current, normal impedance, you know the fault impedance. Then you find out the ratio between the normal and the fault current. And based on the ratio, you select the type of the circuit breaker. And then type of the circuit breaker and the normal current rating. Then you refer the table 8.1 of the AS3000 2018 edition. Then you can find out the appropriate for loop impedance. So this is the way we calculate the for loop impedance like this. Now this is this program is given. So there will be the supply voltage is a 0.280 supply system, and then the distribution both of the consumer may got the cable is a 25 millimeter square cross in the area and a 15 meter long. And also the final circuit 6 millimeter squares are cross in the area 25 meter long. And for applied, so the applying 40, that impedance is a 3 ohm. Final circuit, there will be the cable size is a 4 millimeter square and a 25 meter long. And distribution of consumer mains are their cable size 35 millimeter square and a 50 meter long. So we have to find out the following impedance, and also we have to find out the maximum fault current, and applying the system is a 3 ohm, we have to find out the fault current. So those things you have to find out. So in this case, we have to refer the appropriate table 25. So in this case, you have to utilize the appropriate manufacturer information. Manufacturer information means the type of the conductor crossing the area and the length and what should be the appropriate impedance. So this is you have to refer the appropriate manufacturer table suitable for your cable. So this cable is a 25 millimeter, 50 meter. So in this case, 50330 ohm. So this is that you get from the manufacturer table. Similarly, 6 millimeter square, 25 meter, 4 millimeter square, 25 meter, 35 millimeter square, 50 meter. So those impedance you got, you add all impedance, you can calculate the for loop impedance. And after that, though you got the for loop impedance, supply voltage 230 volt. So the supply voltage by the for loop impedance, you got the fault current. So fault current you can calculate. By this way, you can calculate the fault current. So after you know, sometimes you also have to calculate the maximum circuit length. How much circuits length should be utilized. In this case, we have to find out the Z internal impedance. So this equal formula we have to utilize. So Z internal impedance is 0.8 multiply supply voltage divided by normal current. So this is the way we calculate it. So the maximum circuit length we calculate by this way. Okay, this problem is a final circuit. Final circuits are supplied a load consisting of the range in a domestic installation. It's produced by the 32 ampere Type C circuit breaker. So the way to find out the maximum internal follow impedance and also the final circuit based on the 230 volt and supply voltage are available. So the firstly we have to know about the 32 ampere Type C circuit breaker. 32 ampere Type C circuit breaker. So you refer the table 8.1. So this is table 8.1, 32 ampere Type C circuit breaker. So there will be 32 Type C. So there will be the follow impedance is 1 ohm. So from here you got the follow impedance is 1.96 ohm. 32 ampere Type C circuit breaker.
Well, we need to pay the my God. Yeah,
Oh my.
I'm on any baby. Okay. Yeah. When you name a couple of times, I'm doing that.
So that then you got the here you got the upward impedance. Then you multiply with the this one, and then you multiply with the internal impedance. You multiply with 0.6, 0.8. Then you got the impedance. So this is the way we calculate. The next one is we also have to decide the maximum circuit length. So what should be the maximum circuit length? So we utilize this formula. M maximum is 0.8 multiplied U0 SPH SPE divided by IA rho SPH plus SPE. M maximum is maximum root length of your cable. U0 is a normal supply voltage. Rho is a resistivity of the conductor. So then you substitute. In this case, 22/5 into 10 power minus 3 for the copper conductor. Millimeters unit is ohm millimeter square divided by meter. And for the aluminum, 36 into 10 power minus 3 for the aluminum. And IA is a trick current setting. So trick current setting is an ampere. SPA cross-sectional area of active conductor. And SPE is a cross-sectional area of the protected active conductor. So those things are you have to find out. So the if you know the supply voltage, U0, SPA is cross-sectional area of the active conductor, SPE is a cross-sectional area of the conductor, IA is a trick current setting, rho means the resistivity of the conductor. Then the load factor you substitute in the formula, then you can calculate the maximum root length. So this means how long are you should draw the cable. This is the maximum circuit length. This maximum circuit length is depending on the several factors. They include the supply voltage, also conductor, that is cross-sectional area, also the active conductor cross-sectional area. In the meantime, you have to set up the trick current. Trick current is how much current setting you have to be utilized at the circuit breaker. the peak current setting, and also resistivity of the conductor. Those factors are determining the maximum circuit length. So if you put the all data, how much of your conductor side will be utilized? Conductor side depending on the supply current. In the meantime, conductor resistance, conductor size, and resistivity, supply voltage, and how much current you need to be quick reading, quick current reading. Those factors you substitute in the just formula, then you calculate the maximum circuit length. So the maximum circuit length is an important aspect. So that when we are doing the emitter protection is important. When the current is excessive, it can cause an overload. In the meantime, excessive fault current happen, it can fault leakage current happen. So that because of the excessive fault current, it can cause a insulation failure. When the insulation failure, you can your circuit, the whole thing can cause a fire. Therefore, that we have to be aware of the distance. So therefore, in this case, how to select the appropriate cable size, we have to utilize the EL0018 rule to select the suitable cable size. So this is the how to select the cable size and how to select the how long you should run the cable in the whole circuit. We calculate by this way. In the meantime, any heat energy production. When the electrical current is flow into the wire line, so depending on the current, resistance, and the time, heat energy can happen. So heat energy can be calculated by the formula H equal to I square RT. A is the heat energy in joule, I is the current, I is the resistance. So the fault current, normal, this is the red one is the normal current, and red one is the fault current. So when the fault current happens, fault current is a much more than the normal current. So that all the circuit breaker need to operate it before fault current level reach the maximum. When it reach to the 25% of the peak, the circuit breaker must operate. Otherwise, once the fault current reach the maximum point, so equipment has already been damaged. So this is a no point to provide the protection equipment. Therefore, this is very important. When we are setting the appropriate protective equipment, before reaching to the peak point, about the 25% of the peak is reached, that time circuit breaker must operate. So this is the way we protect the circuit breaker. So circuit breaker setting is an important aspect. Another thing is we have to follow up the ASR 3000 2.5/1 cross. So this is the AY 3000 2.5/1 cross 2.5/1. So we look at the what is a cross 2.5/1. Okay, this is 2.5/1 general. So in this case, 2.5/1 is a general requirement. So active conductor shall be protected by the one or more devices that automatically disconnect the supply in the event of the overcurrent. Before such overcurrent attain the magnitude of the duration, that will cause the injury to the person or livestock or the damage because of excessive temperature or electromagnetic stress in the electrical installation. This means that when the overcurrent attain the magnitude, in this case, protective devices must operate. So in this case, our protection against the overcurrent means we have to utilize the overcurrent protection across the cross 2.5/2 and 2.5/3, short circuit protection 2.5/2 and 2.5/4. So the 2.5/2 is the short circuit protection and also the maximum circuit protection. Those things are important aspects. So that we have to follow the appropriate overload current and the short circuit current protection. Those are the cross 2.5/1 of the EL3000 rule. So therefore, the important aspect is there are three aspects. Actual current of the consumer conductor, So this is the maximum demand current, IV. IV means the actual current in the consumer conductor, maximum demand current. Maximum demand current means that when you are install the electrical installation, in this case, you install the light point, you install the socket outlet, you can install the any lighting point, and also heater. We have to refer the AS3000 appendix C1, C2, and C3. So that we see look at about the appendix of C1, C2, C3 of the AS3000. So this is the appendix table. Table C1, C2, C3 are utilized to calculate the maximum demand of the consumer made. So table C1, table C1 means a lighting load group. So then we single domestic installation, we have to utilize the 3 ampere for the first 1 to 25, 2 ampere for each additional 25. And this is the block living unit, 2 to 5 living unit, and 6 to 20 living unit, 25 or more living unit. This is the lighting we calculated. And for the outdoor lighting, that is 75%. And this is for the lighting point. If you can count how many lighting points in the building, then you can apply the appropriate buildings are plan, then how many lighting points. So the we have to refer. If your installation is single domestic installation, 1 to 25, 3 ampere, and additional 25, you add the 2 ampere each. And for the block, 2 to 5 living unit, you follow this rule, 6 to 20 and 21 for more. Similarly, socket outlet, they are there not exceeding 10 ampere, single domestic, you refer as this rule, block living, you refer as this rule. And socket outlet more than 50 ampere, you just take the 10 ampere. Electrical installation, more than a 20 ampere socket outlet, you can take the 15 ampere. This is depending on the load group. Depending on the load group, you can select the appropriate maximum demand current. In the meantime, if you install the range or fixed circuit heating or the instantaneous water heater, storage water heater, those are the load group. So table C1 for the domestic installation load group. So this is I just explain you the what is the how to calculate the maximum demand of the electrical circuit. We refer the table C1, C2, C3. So more detailed aspect I will explain in the electrical trade study. And this is the table C1 for the domestic. And table C2 for the industrial. This is the table C1. So that AS3000 rule, you can refer the page of 466, 465 and 66, you can see the table C1. And then you can see the example problem. You can look at the example problems of page of 468, also the page of 469, and also page 470. Those pages are on the those pages are we can look at the example problem. So this is the domestic installation. We use the table C1. Non-domestic installation, there are two types of the load. In this case, we have to utilize the table C2. Residential institution, boarding house, hospital, accommodation, house and motel. We use the domestic installation. Non-domestic, they are low group. In the meantime, factory, shop, store, office, business premise, we utilize a non-domestic installation. This is also we utilize a that's low group. So in this case, lighting and the socket outlet, we refer the those group. So this is for the low groups selection. So this is for the non-domestic installation. We refer the table C2, and then you are also look at the table C2, and then you can follow the some example problem how to calculate the consumer installation. The next table C3 is a maximum demand method, non-domestic installation. This is based on the energy demand method. Every 1 meter square, how much of volt ampere happen depending on the office car park. Depending on the office car park and you can calculate the maximum demand. So those maximum demand calculation for the domestic car office and also the retail shop, warehouse, and light industrial complex, we calculate the maximum demand. So that maximum demand is depending on the area. You look at the area of your electrical installation, then you can determine the appropriate volt and their range. So this is the three things we have to refer. So the AS3000 rule. So table C1 for the domestic electrical installation, table C2 for the non-domestic installation, and table C3 for the maximum demand method based on the energy demand method. So this is the way we calculate. Therefore, when you are selecting the appropriate circuit arrangement, the first thing is IB. IB is an accurate current flow into the conductor. This is related to the maximum demand. So to calculate the maximum demand, important one is we have to refer the AS3000 rule, appendix data C1, C2, C3, C1 for the domestic installation, C2 for the industrial installation, and C3 for the energy demand method. So IB is we have to calculate according to by referring the AS3000 rule, appendix data C1, C2, C3. This is the IB. IA is protected device rating. Protected device rating means we have to utilize appropriate circuit breaker rating and a fuse rating. So how to select the protected device rating? We refer the AS3000 rule and table 8x1. So this is the AS3000 rule. We go back and look at the table 8x1. So this is the table 8x1. Table 8x1 is we use this is the table 8x1. We got the circuit breaker, type B circuit breaker, type C circuit breaker, type D circuit breaker. So they are the operation time is 0.4 seconds. In the meantime, you can also utilize the fuse. Sometimes circuits are protected by the fuse. So HRC fuse operating time is 0.4 seconds. Normal fuse is 5 seconds. So how much fuse are protected by rating and also protected circuit breaker. So this is for we have to select the appropriate circuit breaker and we have to protect this device rating. So this depending on the fault loop impedance. So fault loop impedance means that when the electrical fault happens, at the conductor to fault, how much to the resistance? This is the fault loop impedance. You need to calculate the fault loop impedance. Then depending on your kind of the circuit breaker selection, then you can determine the protected device rating. So this protected device rating is the one. This is for the IN. IN is a protected device rating. IZ. IZ is continuous current capacity, carrying capacity of the circuit. Continuous current carrying capacity of the conductor means you have to refer the AS3008. AS3008 is this is for the cable selection. So the cable selection rule, we have to refer the AS3008. How to utilize the AS3008? I will explain in the electrical trade. Now that I am teaching the electrical engineer aspect, overview of all the system, all the reassessment, all the circuit selection, I can teach in the overview. And details are selection, detailed cable selection, details are installation, I will teach in the electrical trade. So this goes include the three aspects. Electrical engineer, designing looking at the whole system, and also the electrical trade. This is the detail aspect. And electrical diploma. This is for the bridging between the electrical engineer and the electrical tradesman. So there are three aspects are included in the Bachelor of Applied Engineering. Now that I'm talking to you about how to arrange the whole system current, the equipment. So how to set the protected devices, how to configure with your conductor, supply conductor, and also how to select your cable side. I am giving you the overview picture. So there are three aspects of the current. In the electrical installation, there are three current you have to be aware of. IB is actual current in the conductor. maximum demand current. Maximum demand current is we have to refer the EL3000 appendix table C123. So this is the EL3000 rule, appendix table C123. Go and look at this EL3008. So the table C1, C2, C3, you can get it. So table C1 for the maximum demand calculation, depending on the lighting load, socket outlet, how many domestic electrical installation, how many block, you can select the appropriate current. This is for the maximum demand calculation for domestic. And table C1 for the maximum demand calculation for domestic. And table C2, table C2 is a non-domestic installation. Non-domestic installation include the two kinds of the load: residential institution, hotel, boarding house, hospital. This is the one group. And factory, shop, business, school, those are the another group. So two kinds of the load group. Depending on the two kinds of load group, whether you are installing a lighting or power or socket outlet, then you can calculate the maximum demand. So this is the way non-domestic installation. Table 3 for the you calculate this area, look at this your drawing, then you can determine how much volt ampere. So this is the things electrical current you have to calculate. This current is an IB. IB means depending on the current maximum demand calculation, you can select the IB. IM means protected device rating. Protected device rating means that you have to refer the table 8x1. So table 8x1 circuit breaker rating. Here is the table 8x1. You can look at the circuit breaker. Whether you are using the circuit breaker type B or type C or type D, or the protected fuse, you can select the circuit breaker. So this is what the circuit breaker rating.
呢個係而家 meeting 啊，呢個係個 meeting 啊嘛。你想熄咗佢
So this is for the circuit breaker rating. Circuit breaker is a table 8x1 circuit breaker rating. So you look at the table 8x1, there will be the type B, type C, and type D circuit breaker, and also the final sub circuit. Final sub circuit. So this is for the your depending on the output impedance and depending on your circuit type of the protected equipment, you can calculate the protected Y rating. So that protected Y rating is this one. This is for the IN. IZ means the continuous current carrying capacity. Where the electrical current is drawn by the supply system, we have to select the appropriate continuous current rating by using the EL3008. So that this is the configuration. IV must be less or equal than the IN or the less or equal than the IZ. This means the actual current must be less than or equal the protected device rating, or the less the protected device rating must be less or equal than the continuous current carrying capacity. So this is the way we have to arrange the supply wire. In the meantime, another thing is that I2 is less or equal than the 1/459 IZ. I2 is effective operating of the protected device, and IZ means a continuous current carrying capacity 1/45. So you multiply with 1/45, IZ by 1/45, it must be less or equal than the I2. So this is for the effective operation of the protected device. So this is the way we have to select the appropriate current rating. So this is the configuration of the electrical circuit. Okay, so this today lesson, I'm talking about the electrical engineer aspect. Electrical engineer aspect is I talk about the rule and regulation. I summarize my lesson. For the electrical engineer, we have to be aware of the appropriate standard rule and regulation. So the reassessment is the first thing. So we have to operate according to the reassessment. Before you start in any job, you need to assess a risk. How much a risk can happen? So this is important aspect. So in this case, the reassessment is important aspect. So in this case, we have to repair the duty of care, New South Wales Work and Safety Act, and you have to follow the appropriate reasonable practice. This is also important aspect. Now this is for the legal framework I'm talking about. We also have to follow the appropriate risk assessment, how to design a risk. And as an electrical engineer, you need to design an electrical system. In this case, the most important thing is the AS3000 rules have to be utilized. So I explain you the AS3000 rule. And also I talking about the risk assessment data. And then firstly is important is we are talking about the contract procedure. Contract procedure bidding or your ethical practice I explain about. And then I talking about the protection system. Because you are doing the electrical system, important one is a protective device is an important aspect. I talking about the follow impedance and also the follow impedance calculation, also the protective device rating. We talking about how to set the AS3000 rule, how to refer the table, how to select the current circuit configuration. Those are I expect. This is for the electrical engineer aspects. Okay, this is first part is an electrical engineer aspect I explained about. Second part is we are talking about the electrical trade practice. Electrical trade practice 1. For the higher electrical trade aspect. Okay, we're talking about the lighting circuit. So this is a one-way switching for the look at the light circuit one. So this is for the active, the neutral, so light by 1, light by 2, and connected to the neutral. So the firstly, electrical, this is the active, active and it's a neutral. Circuit power to the light path. So this is for circuit going to the switch and go to the light. And also we have to provide the separate wiring for the control. Likewise, a button holder or the ceiling rose. Power for the main light is taken from which the light is active. So this is for the first light and second light likewise. So this is for the circuit diagram. One-way switching more. Every one way. This is a switch connected to the light by 1 and light by 2. So this is for the, when you see the socket out there, this is the controls diagram. So this will be the switch. This bottom 2 are the switch. This is for the your light. So at the back of the your ceiling rose, you can connect like this. So this is the arc is connected. Here is a switch wire, active wire is red one. So active wire go to the this is the switch C12. C12 is at the switch. So the active wire go to the C. Another from this C, another go to the C point. So this is a common terminal. So active wire go to the first switch as C, another switch C point. Then number 1. So number 1 point connected to the your light point. So light point here, this and this one. So this top and bottom one, they got the connection. So they got the connection, they go to the here. And after that, the another side is connected to the opposite side. So opposite side point, this is opposite point. This is connected to the neutral. and then connected to neutral. Then up wire is a given on your light. So this up wire connected to blue wire connected to up. So this is the way we can connect it. So this will all the active neutral and the light have been connected. This is a look at the switch. Look at the switch point. Look at the switch point means active wire go to the C point and from another C point go to another active wire. So this is the C1, 2s are the switch. So active wire go to this C point, another C point. And then number 1 connected to the light wire. So before this point and this 2 point, we have to connect your light. So we can connect, and out of the opposite side, we connected to the neutral wire and connected to neutral to the neutral. And then a terminal is given, so the all a terminal connected join like this. So this is for the look at the switch installation. So then looking at the switch wire, they require the main circuit active to be looped from the one switch plate to next and maximum one active neutral up and the switch. So this is for the look at the switch installation. So when you are connected, important one is a switch must come in fast. Active to switch and then light to neutral. If you put the light after you put the switch, it's around. Because switch must be installed at the active wire. And here is a connection of the two-way switching circuit. Two-way switching circuit, this is the switch 1, this is 2, this is light to neutral. So this is a two-way switching circuit. Two-way switching circuit, this diagram you can refer as a two-way switching. Look at the switch suitable for two-way switching circuit. So this is the switch. So there will be active wire go to C, and then number 1 is connected to the number 2. This number 2 point connected to number 1. After this C point connected to the light, and after that this one coming is a neutral wire go to a neutral point, and here is a connection. So this is the two ways light connection. This is circuit diagram. This is accurate wiring diagram. So two-way switch connection diagram we can utilize like this. It is two-way switching. So if you also so two-way switch means the appropriate number of the final circuit need to be arranged to protect the overheating of the wire. And then it needs to be separate lighting and a power circuit. Lighting circuit and a power circuit need to be separated. And then cable side is you have to utilize a cable side by referring the AS3008 or the AS3000 2018 debate selection. Addition, you have to select the cable side. So the 2000s are AS3000 effective stable CA utilized to determine the maximum demand. So the standard cable size is a 1.5 millimeter square. So this is what the standard cable size, and minimum size and non-domestic installation can be 2.5 or 4 millimeter square cable. So this is for the general information regarding the connections of the electrical lighting system. In the meantime, you also have to know about the operating temperature limit. When we are installing a cable is installed in environment with the higher or normal ambient temperature or within the thermal insulation need to be derated to carry the less current or upgraded in the side. So this is for the normal operating temperature. We have to derate the cable. So the upgrading the temperature rating. V75 is a 75 degrees centigrade operating temperature. Instead of using the V75, you can use the V90. Because of the, if the cables are derated, means that you can increase the cable size or you can utilize the cables upgrading the temperature rating. So depending, because of the only single cable is installed in the circuit, is not a problem. But if you are using the multiple cable, they will mutually induce the electromagnetics and mutually induce the voltage. Low electromagnetic and voltage will increase the current. So this is why we have to select the appropriate derating of the cable side is important. So the cable side derating is you can do by two ways. One thing is you can select the bigger cable by using the AS3000. You can select the one step bigger cable AS3008, one step bigger cable, or you can upgrade the temperature rating. So instead of using the 75 degree centigrade, you can upgrade to P90. So this is the ways that cable derating is also important aspect. And another thing that we also have to provide a fire safety. We have to protection against the thermal effects. Land boilers are the high temperature sources, so the downrise require the education area in roof space to round the heat to dissipate, or otherwise they can start the fire. Small light cannot be too close to the object. So this is for the ceiling, appropriate ceiling side. This is for the you use the thermal insulation, and also the you use the any transformer. So above BNC. BNC means clearing above the ABC. A is clearing above the luminaire. So in this case, incandescent light is 50 millimeter, halogen light is 200 millimeter. B is side clearing. Side clearing is 100, incandescent 100, halogen light is 200 millimeter. Here C is clearing from the thermal insulation. That will be the incandescent 50 millimeter, halogen light is 200 millimeter. D is clearance from the transformer. If you use the transformer, the clearance is also D. This D means about 50 millimeter minimum. So this is the ways appropriate clearance important aspect. When you are installing the light, appropriate clearance from the ceiling, from the equipment is also important. So this is also we have to utilize at this stage. In the meantime, we have to this is for the fire safety. Because of the lead and the boilers are the high temperature source, downlight require the educate area and roof space to allow the heat to dissipate or that they can start the fire. Spotlight cannot be too close to the object. So this is for the appropriate transformer side, and the boiler rating is also important aspect. And here is you can see about the main switch and the RCD. So this is for the installation is uplink, neutral link, and RCD neutral. So this is the residual circuit device is installed from the main switch, go to RCD and connected to the light. And also the neutral connected to the RCD neutral, and then RCD neutral connected to neutral link, and also neutral link is combined with the uplink and go to supply. So this is for the main switch connection, RCD and the lights are configuration. So the class 1 is you have to complete this diagram. So here you got the light by 1, light by 2, light by 3 are given, and switch 1, switch 2 are given. At the neutral arc, you have to complete your circuit diagram. So this circuit diagram given, you have to connect this as real connection diagram. Then you have to choose a correct answer. In the look at the switch system, the active and neutral wires are firstly connected to switch, and then spray wiring is installed for the control. The active and neutral wires are firstly connected to light, and then spray wiring then connected to this, taken for the switch. And then here is the uplink, neutral link, and then RCD neutral link. Here is RCD given. This is a main switch, and this is active neutral arc. So that you have to complete this circuit diagram. The whole wiring system, cable is widely used. How much are cable side? Non-domestic